Here is an introduction to our paper, Identification of Authentic GNSS Signals in Time-Differenced Carrier Phase Measurements with a Software-Defined Radio Receiver. In this paper, we show that time-differenced carrier phase can be computed with measurements recorded by a multi-GNSS SDR receiver such as PyChips, from which user displacement and receiver clock drift can be solved. PyChips consists of open interface open source software that operates in Python environment, in which the computationally intensive tasks are accelerated in C++. It has been developed and made available for educational and research purposes, and it supports the Institute of Navigation GNSS SDR metadata standard. PyChips is able to simultaneously track authentic and inauthentic signals in separate channels, which makes it possible to observe both types of measurements with corresponding navigation data. A random sample consensus algorithm has been introduced to check the consistency among the measurements and data. This slide shows the velocity error magnitude and receiver clock drift rate, which authentic GPS L1 measurements were matched with authentic navigation data, and inauthentic GPS L1 measurements were matched with inauthentic navigation data. The main focus of this paper is to discuss how inauthentic measurements could be identified when they are combined with live or simulated navigation data. It was assumed that the simulated system is sophisticated such that the generated pseudo-range and carrier phase are consistent with geometric distance between the actual receiver position and the simulated satellite position decoded from the inauthentic navigation data. However, if these channels may be driven by a single clock in the simulator, there may be a large discrepancy between the simulator clock and the inauthentic navigation data. Therefore, it is still more likely for RANSAC to choose authentic channels over inauthentic ones.